Hello, Walla peeps. I hope you're sleep deprived, and I hope you're more tired than everyone, and I hope that you are having a miserable time. Anyway, we're going to do 5-5. I'm going to warn you that if you don't understand inverse functions, you should probably go back to 2.7 and get a recap of how inverse functions work. We just did a little recap in this class, and you missed it. So, first what I want to talk about is I want to go through each function, sine, cosine, and tangent. Those are our main focus today. And talk about their domains and their ranges. Okay? This is the part where you're going to want to have this down. So let's start with sine. Okay, sine x, I will remind you of what it looks like. I'm doing this for a very good reason. We go all the way to 2 pi. This would be pi. Pi over 2. 1, negative 1. So here's a dot. There's a dot. There's a dot. 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 So we get this beautiful looking curve. But you will also know that I can also go backwards, correct? That's pi, so probably like negative pi. This is negative pi over 2. So this would be like this. Yes? Okay. I'm doing that for a very good reason. We basically have to restrict the domain because, as we just said earlier, this function does not pass the horizontal line test. It's crossing uno, dos, tres, cuatro, just in this period alone. If I keep going more periods, it's going to keep doing that. And we can't have that. It has to be one-to-one. So we want to talk about the domain and range, but we want to restrict our domain to only parts where it doesn't repeat. I don't know if any of you can tell just by looking at it where those parts would be. Does anybody have a, like, should I restrict it from 0 to pi?
No.
Would that work? No.
From max to min.
But you could go from max to min. So you could go from positive pi over 2 to 3 pi over 2. But you'd be surprised that for simplicity's sake, we actually usually start at negative pi over 2 and go to positive pi over 2. Okay?
I do have a highlighter.
Wow. I'm awesome. So you understand why we're restricting the domain. It has to be one-to-one. Now, there's lots of different places on the graph where you can go max to min all the time, or min to max. But it's convenient for us to go from negative pi over 2 to positive pi over 2 because it's zeros in the middle. So we're going to say then for the sine function, the domain that we're interested in is negative pi over 2 to positive pi over 2. The domain we're interested in. Okay, we know that it's all reals in a normal case, but for one-to-one purposes, it's negative pi over 2 to positive pi over 2. The range is easy. Between what two values are the y's always going to happen? Negative 1 and positive 1, right? It's bouncing between negative 1 and positive 1. So the range is negative 1, positive 1. All right, so then we're going to do our cosine function. Cosine x. All right, so we're going to move you over here for a second. And we're going to go with cosine. Now cosine, starting on just 2 pi, pi, blah, blah. So cosine starts at its max, right? Starts up here. Then it's at 0. Then it goes to its min. And then it's back to 0 and then back to its max. So this is your cosine curve. Something like that. And again, it doesn't pass the horizontal line test. So we have to restrict the domain. But this time it's actually a lot easier. You don't have to go to negative because you have a nice little stretch right there. You're still going max to min, but in this case it starts at 0. So that's a nice starting point for us. So we're going to go ahead and say that our domain for cosine is going to be 0 to pi. And the range is still, what is the range? Negative 1 to 1. Right? Okay, so, and we'll do tangent in a second. I want to put them on the same screen, so I'm not gonna, what am I not gonna do? I'm not going to do tangent yet. We'll do tangent next. Okay, so, we're talking inverse today. So, everything that we did so far should be like, duh, I already know this. But what is then the domain and range of sine inverse? And if you were with me earlier and we talked about how they're opposites or they're reversed, then the domain for sine inverse should be what? Negative 1 to 1. And the range would be negative pi over 2 to positive pi over 2. They're backwards. You could even like graph this little guy if you really wanted to and go like this. And that's more or less what the inverse sine function would look like. By the way, this is the notation for inverse. It always has been the little -1 there. You want to put it in front of the x, not after the x, because then you might think that it's x to the negative 1 power instead, which it's not. And also another common word that you'll hear about sine inverse is they'll say arc sine. I assure you that arc sine is the exact same thing as sine inverse. Some calculators, like dumb Casios, have arc sine instead of inverse. Okay, but other calculators, like smart ones, like the TI-83s, they have the little inverse button. They're consistent in that way. Anywho, that's our little spiel on Casio. Okay, so actually I can do this. This is kind of in my way. Okay, so in this case, same idea. We're going to do cosine inverse. So what's really funny about this section is that it's not really that hard, but you have to just constantly be aware of the domain and the range to do your homework. So don't think you're going to be graphing inverse functions if you're already scared right now. You're not going to be graphing them, but you do have to evaluate them. And when you evaluate them, you have to make sure that the domain fits. If I say to you, what is the sine inverse of 2? You should know that, wait a minute, you can't do that because 2 is not part of the domain. Do you see what I'm saying? So this is why we're going over this. And this is why it's very important that you at least have the domain and range for the sine, cosine, and tangent on a note card somewhere because you might forget. So for cosine inverse, same thing, we're going to go backwards. The domain is going to be negative 1 to 1. So both functions have the same domain, but the range of this function is going to be 0 to pi. Jock? Nolan?
Yeah.
What are you doing over there, Nolan? Nodding your head? Okay. Are we okay with that? By the way, this would be arc cosine, and then arc tangent, arc secant, arc cosecant, whatever. The arc just means inverse. So now we're going to do tangent. Let's go into the little tangent scenario. Yes, sir.
How would we graph the cosine?
You just make the mirror image. But again, you're not going to have to graph them. I was just showing you that it still works with the whole, y equals x thing. But again, you're not graphing the functions today. If you look at the homework at all, it's all about evaluating. So tangent x, I'm going to graph that one for you, again, just so you can see. We've got negative pi and positive pi. If you remember, tangent has asymptotes at negative pi over 2 and positive pi over 2, and then there's the middle, and it does this little guy. That's what the tangent looks like. Yes? So for tangent, the domain is actually not even, it's not a bracket. That's for one thing. It's not a bracket because the domain goes from negative pi over 2, but it doesn't include pi over 2. That's why the asymptote's there. It doesn't include pi over 2. In the other cases, you have brackets because it includes the endpoints. And over here, we have positive pi over 2. Your range is going to be everything, right? Because it's going to go down forever
all real
and go up forever. So it's going to be all reals.
Mm-hmm.
So then your tangent inverse is going to have a domain of all reals. That's nice. And your range is going to be negative pi over 2 to positive pi over 2. And it's interesting to note that this little guy will be like, I'm not trying to do this. And then you'll have asymptotes like this for the inverse function. Because these vertical ones will become horizontal ones, and then this little, it's going to be all weird looking. Again, you don't have to graph them. I'm just showing you how cool it is that it actually works out. But anyway, so this is your tangent inverse. Again, it could say arctan, but there you go. All right, so what I want to do is kind of do some examples with you and see if we can't figure out why this is going to matter. All right, so you have all the domains in front of you, because even I, at times, forget them. I confuse them sometimes. It's always harder to go backwards, especially when you're so comfortable going forward. So, thank you, Joshua, for your vote of confidence here. So this says, find each value. Mark, how are we doing on time? What does it say? That how much time has passed?
11:15.
Okay, we're okay then. Sine inverse of 1/2, sine inverse of negative 1/2. And now if you have your unit circle, that would be really convenient to have as well, to have it out. Okay, I'm going to go to part C first because it's the easiest one to get out of the way. This is the input, this is the domain part for sine inverse, and we just said that the domain for sine inverse is from -1 to +1, and I'm pretty sure that 3/2 is 1.5, right? So 1.5 is not in the domain of the sine inverse function, so this is just like undefined, if you want to call it that. Okay, you can't do that because it's not in the domain. So the domain of sine, that's the first thing you have to check. This is the input. You want to do inverse, right? So the sine inverse, the domain is between -1 and +1. This number has to be between -1 and +1, and it's not. This is not between -1 and +1. It's bigger than 1.
What is that? 3/2?
3/2.
Oh, okay.
Yeah, sorry, 3/2. So that one's the easiest one to do because it's just not doable. So it's not in the domain, so it's not defined, so you just put undefined. Okay, what about these little guys? 1/2 is definitely between -1 and +1. So is -1/2. So we can do these two. So the second part of the issue, that's the first thing you have to check, is the domain. Do you have any issue with the domain? Secondly, you got to think backwards. Okay? Remember that if you have your unit circles, and you have like a, I'm just going to do half of it, because this is positive pi/2, and this is negative pi/2. And that's my domain. This direction, that direction. Over here, not so much. Okay? So what they're asking you for is, if you're thinking about it backwards, what number between pi/2 and negative pi/2 has a sine value of 1/2? So if you go to your unit circle, and you're looking at that, which angle measure, basically, has pi/6, right? So the answer here is pi/6. So it's not hard, but it does require you to think backwards a little bit, and that sometimes can get some getting used to. But that's all it's asking you for. This guy, same thing. Once you've determined that -1/2 is in your domain, now you have to go and say, okay, well, what angle measure will give you a -1/2? But 11 pi/6 is not within the range of the inverse function. It has to be something between negative pi/2 and positive pi/2.
Negative pi/6.
Which means that at this point, it wouldn't hurt for you to convert some of your unit circle values to negative values. In other words,
Negative pi/6.
this is negative pi/4.
Oh.
It's also 7 pi/4. On your unit circle, it's 7 pi/4 because you're going in the positive direction. But if you go in the negative direction, it's also equivalent to negative pi/4. So I'm going to tell you right now, in case you want to write these down, when you're at 11 pi/6, 11 pi/6 is the equivalent of negative pi/6. You might want to write that down. 5 pi/3 is over here, is the equivalent of negative pi/3. And those are pretty much the only ones that are in that quadrant, right? So if you have those, then we can do this a lot faster. So when you're going down there, which one has negative 1/2? Negative pi over 6. You guys said it was 11 pi over 6, but we want to make sure that our answer that we give has to be in the range of sine, which is negative pi over 2 to positive pi over 2. So it has to be a number in this region. All right, so this is going to be negative pi over 6. Yeah? Awesome. So then we're going to also do another one here. What about sine inverse of 0.82? Now remember, as long as there's no degree symbol, this is radian, okay? So when you see decimals, you tend to want to think that it's not radian because there's no pi. When there's a pi involved, you always know it's radian. But this is radian too, it's just a decimal instead. It doesn't have a little degree symbol, so it's radian. We have that little guy, and then we have, what's this other little guy? 1/3. Want to evaluate those two. Well, there's no unit circle like that. Number is like a decimal, so we can't really find it on here because we don't know what that is. But you can use your calculator, and that's why I want to show you how to do this. Oftentimes, students will confuse inverse functions with reciprocal functions. This is not 1 over sine, by no means whatsoever. 1 over sine just takes the value and it flips it over. This is literally inverting x and y, so it's not the same thing as a reciprocal function. So on your calculator, above where you have sine, cosine, tangent, you will see in a different shade, maybe it's yellow, maybe it's blue, maybe it's green, I don't know. Mine's light blue. You want to hit the little sign with the -1 on it. So I'm going to go, make sure your calculator's in radian. That's first and foremost. Mine's in degree. So I'll change it to radian. And then we're going to go second sine 0.82. And I can do this because 0.82 is still less than 1. So it's in the range, correct? So I do that and I get 0.9614. Yeah? So that's the answer for the 0.82 one. So you can use your calculator. 0.961. 1/3. 1/3 is also within the range of your -1 to +1. So what's that going to be? Sine inverse 1 divided by 3. What'd you get?
0.3.
So 0.340.
Yeah.
It's 3398. So 340. If it asks you to do 3 decimal places. And then it'll tell you different things. It might say, I would always suggest that when you are doing these, that you do 3 decimal places if it doesn't indicate what you should do. On WebAssign, it might say it wants 2, it might say it wants 4. If it doesn't say, it's always a good idea to at least have 3. Okay? You shouldn't really have fewer than 3. All right. So that's how you use the calculator. And then we're going to do some other little dudes here. Let's see, I'm going to clear this little board. 2 more here. And I might even, unless you still want to see more, I'll do some cosines, I guess. Sine inverse of sine.
Is this the same directions?
Pi over 3.
So,
Yeah, they want you to evaluate, but in some cases you have to do it a little differently, like in this case, because it's got the sine and sine inverse of sine. Okay, so when you have a function and its inverse together, they're supposed to cancel. You guys saw that when I did it at the beginning with the linear function. The 2 functions cancel together, you get x back. You saw it with the quadratic. The square root squared cancels, you get your x back. So ideally, these would cancel and you would get your x back. However, because of the domain issues, you have to make sure that the value here of x is within the range. Does that make sense?
Yeah.
And the output as well, okay? So in this case, pi over 3 is within 0 to -1 to 1, right?
Yes.
So in this case, it's fine to cancel them. But 2 pi over 3 is not so much. 2 pi over 3 is like 2 times 3.14 divided by 3. This is going to be larger than 1. This is larger than 1. So we can't just cancel it out right away. What we can't do is figure out what is the sine of 2 pi over 3. This is regular sine. This is not inverse sine. This is just what is sine of 2 pi over 3. So on your unit circle, what is the sine of 2 pi over 3?
it's Root 3 over 2.
Root 3 over 2. So now what this is really saying is root 3 over 2. And this number is within my range. Does that make sense? So there's like a little extra step. You can't just cancel them out if this number is not within your range, but this number is. Root 3 over 2 is okay. So now we're thinking backwards and we're asking what number between negative pi over 2 and positive pi over 2 gives you a sine value of root 3 over 2.
Pi over
Pi
3.
over 3. Y'all need to get comfortable with your trig. You're comfortable with your unit circle, but you're not comfortable with your trig. And you're going to have to be able to reinvent the wheel on your next test, just so you know. So yeah. So you'll be able to use obviously the unit circle that you come up with. But could you imagine what's going to happen to your entire test if you have no unit circle, but you make yours on the test and you make it wrong? Like, you see what I'm saying? That would be a problem. So you really need to make sure that you know how to do that. All right, so that's enough sines. Let's go to some cosines. It's much the same way, but let's do some cosines because it has a little bit of a different range. The domain is the same, but the range is a little different. So cosine. We want cosine inverse root 3 over 2. We've got cosine inverse 0. We've got cosine inverse 5/7. Are any of these a problem? Are any of these values not within -1 and +1? I'm sure that that's less than 1 because it's 5 over 7, so it's not 7 over 7. 0 is definitely good. Root 3 over 2, what is that? It's something, yeah, I know.
It's less.
It's less than 1. Do you know how I know that? Because all of the circles, all the values in your circle are less than 1 or equal to 1, right? The root 3 over 2, all of the values on your unit circle are less than or equal to 1 and -1, right? So this is good. It's on your unit circle, this is a good number. So now all we have to do is think backwards. What value between 0 and pi, right? Because I think the range for this little guy is 0 and pi. Yes? So what value between 0 and pi is going to give you root 3 over 2?
And negative
Darn
pi
it.
over 6.
Oh, so now we have two values. But negative pi over 6 is not between 0 and pi. Shut up. That was Joshua, by the way. Right?
Yeah.
So, again, that's why I wanted some cosine. Because sine is between negative pi over 2 and positive pi over 2. For a cosine, it's between 0 and pi. So you want to go with the positive pi over 6. Yeah? No.
The trick.
I know, well, I'm sorry. What about cosine inverse of 0? What value between 0 and pi will give you a cosine value of 0?
0.
Pi over 2, not 0. Pi over 2. Good job, Maddie. Pi over 2. At pi over 2, the x-coordinate is 0. Okay? And this guy, because 5/7 is not on your unit circle anywhere, right? That's when you know that you got to use this little guy right here. See this little guy? You're going to go cosine inverse of 5/7, and we're going to get 0.775.
Is that 9?
5.775. Oh, what? This is the cosine inverse 5 over 7. That is not a 9. If it was a 9, it would be closed.
It looks like it's almost closed.
Almost is not closed. Julio.
How's that a fuck though?
How is it not? How about you just be quiet?
Looks like an ear.
Okay. Anyway, all right. So what about cosine inverse of cosine 2 pi over 3? Is this a problem? Can I just cancel those out? What is the determining factor for whether or not I can cross them out? This number has to be between 0 and pi. Is it? 3 pi over 3 is 1 pi. This is 2 pi over 3.
Yeah.
So yes. So yeah. Boom. Chakalaka boom. Answer 2 pi over 3. What about cosine inverse of cosine 5 pi over 3.
No.
Can I cancel those out right away?
No.
No, because 5 pi over 3 is bigger than 3 pi over 3, which is 1 pi. So this is too big. It's not in the range. Okay? So now I have to go backwards and say, okay, what is cosine 5 pi over 3?
1/2.
1/2. So cosine inverse of 1/2, and now I can do it. What's cosine inverse of 1/2? Which angle measure will give you a cosine value of 1/2? 3?
Pi over 3.
Pi over 3. I thought you said 3 though. I was like,
He did say 3.
not negative pi over 3. Pi over 3. All right? So you guys are doing well. This is awesome. Okay? Then we have some tangents, and we'll call it a day. I'll give you some examples of tangents, and then you are good to go. No, you can't go home. But you should probably be checking what the domain or range is for tangent. Tangent's the fun one, because tangent is, the domain is anything. Remember? Well, you don't have to worry about the input for tangent inverse because it's anything goes. You have to worry about the output, but not the input. Tangent inverse of 20 are the examples we got here. So tangent inverse, they're all fine. They're all real numbers, so unless they were like imaginary or something, they all count. They're all part of the real numbers. So what is the number between negative pi over 2 and positive pi over 2 that gives you a tangent of 1? Now, I looked at some of your unit circles, by the way, and some of you have not gone through and put all your tangents in there. You really need to, because this is pi over 4. And it's pi over 4 because at pi over 4, it's the only time where the x and the y coordinate are the same. And since tangent is a ratio of x and y, sine over cosine, if both sine and cosine are the same, you're going to get 1.
Isn't it at 5 pi over 4 too?
Well, the positive 1, negative 1, but positive 1 is going to be, yeah, on the other side. But which one is between negative pi over 2 and positive pi over 2?
So for tangent, it has the same.
Tangent doesn't have issues with the domain, like what goes in, but what comes out has to be between negative pi over 2 and positive pi over 2.
Oh, okay.
All right? So, so in this case,
Pi over 4.
when I think about the fact that there's more than one answer, but which one of those answers is within
Yeah.
my range? So it's pi over 4. What about root 3? What value between negative pi over 2 and positive pi over 2 gives me root 3 for the tangent?
Pi over 3.
Pi over 3 is my friend. And then, of course, the last example, you can't really do with the unit circle because you don't have 20s on there. So we're going to go back to this little guy, second tangent, so that's going to be inverse 20, and I get approximately 1.52. And in case you were wondering, the decimal approximation of negative pi over 2 is negative 1.57. So this is just bait it in. It's just shy of the domain there, or the range. Alrighty, so that is basically what you're doing. But of course, I know you're probably thinking, why did you make this whole stuff? Because you have to know why. You can't just be like, here, do this. You gotta know why. But we can turn that little guy off. Your WebAssign will be posted next period, I guess. It's not actually on there yet, but you'll see it in a few minutes. I'm gonna go post it right now. Bye-bye.